Good morning, students. So after having discussed about the number system like natural number, whole numbers, and rational number, irrational number, right? So today we are going to solve the exercise problem of 1.1. So look at the question number first. NCERT is 0 a rational number, or can you write it in the form of p by q where p and q are integers? So we have to check 0 is a rational number or not a rational number. So we know that by definition, if a number can be expressed as p by q form. See, so this 0 can be expressed as 0 by 1. It means p by q. What are p and q? P and q are integer. So p 0 is integer, and q is what? 1. 1 is also an integer. So yes, we can conclude that 0 is a rational number, right? Because by definition, if a number can be expressed as p by q form where p and q are integers and q is not equals to 0, is said to be a rational number. Okay, so this is your first part. Even you can write here p equals to 0 and q equals to 1. Now look at the question number 2. Find 6 rational numbers between 3 and 4. So we have to find 6 rational number between 3 and 4. So there are 2-3 methods to find. So I am using the easiest one. So 6 rational number between 3 and 4. So now check, are these number lying between 3 and 4, means greater than 3 or less than 4 or not? I mean decimals. So it's very easy to write 3, then start 0.1, 0.2, 3.3, 3.4. How many is we need? So we are needed 6. So 1, 2, 3, 4, 5 and 6. 3.5, 3.6. Okay, but these are in decimal, so let us express these numbers in p by q form. So we can say 31 by 10, now 32 by 10, similarly 33 by 10, 34 by 10, 35 by 10 and 36 by 10. Alright, so this is now coming p by q form. We can further think that we can simplify these fractions more into the simplest form. So which number? See, 31 by 10 is in simplest form because 31 is a prime number. So now this number 32 by 10 can be written as 16 by 5. You can cancel by 2. Similarly 33 and this both are not divisible by same number. Okay, this is divisible by 3 and 10 is not divisible by 3. So we will not divide. Next one is 34 by 10. 17 upon 5. 2 say we can cancel from the number 2. Next 5 7 ja 35, 5 2 ja 10. Similarly we can divide this 2 18 or 2 5 ja, so 18 upon 5. So just write one more steps, divide these numbers, and that are the rational numbers between 3 and 4. Now I am taking one more questions. Question number 3. Find 5 rational numbers. Question number 3. Find 5 rational numbers between 3 by 5 and 4 by 5. So this question is a little bit different from the previous one. Here the numbers are given in fraction. So we can say this 3 by 5 is equals to 0.6. 5 6 are 30. Decimal we have to use. Now this 4 by 5 equals to 0.5 at 40, 0.8. So in between 0.6 and 0.8 you can write any 5 rational number. Make sure in these questions your answers may be different because there are infinite numbers lying between the two numbers 0.6 and 0.8. So you can write any 5 rational numbers. Even your answer may be different from book's answer, so you don't need to worry about that. Okay, make sure the number must be lying in between 0.6 and 0.8. So the 5 numbers rational number can be written as 0.61, 0.62, 0.63, 0.64 and 0.65. Even you may write, or one alternate solution I am writing 0.71, 0.72 and so on, 0.73 and so on. Okay, you can even further change 0.7 to 0.7, having 3 places of decimal you can write. So as I said, there are many numbers. So this is one set of the number, this is second one. Now what you have to do, now remove this decimal and convert it into fractions, and then check whether it is divisible or not. I mean convert this into simplest fractions, okay, as far as it is possible. Right? So I think you understood, and you will do this question. Next question is related to my first lecture, that is natural number is a whole number or not. Question number 4, every natural number is a whole number or not? Yes, because whole number is the collection of all the natural numbers including 0. 0 is extra number. So what we will say, this is the right option, I mean true option. Okay. Second part, every integer is a whole number. No, this is wrong, because there are some negative integers, like you will write this region -2, -3 and so on. -2 is an integer, but it is not a whole number. It is an integer but not a whole number. So it means we can conclude every integer is not a whole number. Okay, however some integer can be whole numbers. Okay, so you will write any negative integer, like you can write -3, -4, any negative integer you can consider over here. Same as third part, every rational number is a whole number. It is not necessary. Next part, third part, every rational number. So consider 1/2 is a rational number. So what is the value of 1/2? It is 0.5. So now check, 0.5 is a whole number or not? No, this is not a whole number. So this statement is also false, and you will write this region, or you may take any fraction, okay, where make sure there should be a decimal. I mean whole number should not come up. Clear? So now let us solve the next exercise. This exercise based upon your the first lecture, I mean basics of real number. Now let us see the next exercise, which is related to the rational or irrational. So before proceeding, exercise 1.2, let us see once again. Let's understand the real number with this flow chart. What is the real number? Real number is the composition of rational number as well as irrational number. Okay, rational number we have already studied about this. Right? Now let us solve question number first part related to this. Every irrational number is a real number. Every irrational number is a real number. So yeah, this is true. Why? The reason is because real number is the collection of rational as well as irrational. So all irrational number must be real number. So we will write this explanation. Now second part, every point on the number line. Let's see what is a number line. If I draw a line and write some numbers like 0, 1, 2, 3, same as -1, -2, this is called the number line. Number line. So according to this statement, every point on the number line, every point like this point or this point, okay, you may take here, I mean anywhere else on this number line, each point can be represented by square root m, where what is m? M is natural number. I mean if we put any value of m, that is what is m? Natural number. if we write any natural number like under root 1, under root 2, under root 3 and so on, this is 1.414 something, similarly 1.732. I have written some of the values after decimal places. So now what we see, if you put any natural number here, we will be having what? Positive values, and positive values can be represented on the right hand side of, positive real number can be shown on right side of this number. Clear? Where we find that, what about this side? This side containing negative number, and we are very sure if we put any natural number, we will never have what? Negative value. It means for these negative numbers we cannot find any under root m. So this statement is false, because we are not getting any number corresponding to this -1, -2, -3 and so on, where under root m gives any one of the values, right? Because natural numbers are positive and the square root of positive real number is what? Real itself, that is positive itself. So the negative integers will not come over there. Okay, so this was second part. Now third part, every real number is an irrational number. Every real number is an irrational number. What we can say about rational number? Real number is also the set of what? Rational number and irrational number. So as per this statement, ki only, this is given, only irrational numbers are real numbers. So this is wrong. Okay, so the next statement is false. Right? Now we are doing one more question. Question number 2 you can try yourself. Okay. Question number 3 I am doing. We know that under root 5 is irrational number, and we are going to show this irrational number on a number line. So how we will show it? To show this, we must know about Pythagoras theorem. I hope some of you have learnt Pythagoras theorem in your previous classes, and if you all have learned, so try to recall. What was it? Or write yourself. Recall, h square equals to p square plus b square. H stands for hypotenuse, p stands for perpendicular, and b as base. Right? So in a right angle triangle, we can apply Pythagoras theorem. See, if ABC is the right angle triangle, okay, then this side is known as H, where usually we take this as perpendicular and this side as base. Okay, so now what we are looking, we have to get under root 5, that is this hypotenuse. We have to take this as hypotenuse in such question. So see, this 5 can be written as 2 square plus 1 square, right? Because 2 square is 4 and 1 square is 1, that is 5. 5 equals to 5. So further we can say under root 5 whole square, which gives 5 only, is equals to 2 square plus 1 square. It means we can say this is going to be h, that is h square, and this one is taken as p and this one as b, p square plus b square. To show it geometrically, we will draw the number line first of all, then write 0, 1, 2, 3. We will not go with the negative side because we will not get what? The square root of 5 doesn't give the negative values. Right? Now the base is what? 1. So 0 to 1. There may be a gap of 1 centimeter, 1.5 centimeter, but take equal gaps. Right? Make sure as per your convenience. Now we are taking this side. Let's start this 0 to 1, means 1 unit we are taking. Now draw using compass a right angle at this point 1. Say this point is P. Draw a right angle at the point P. And now see what is the perpendicular? 2 square. So we have to take only 2 without square. So take 2 units. Okay. Whatever units you are taking. Suppose you are taking 1 centimeter. So 2 centimeter, take distance and draw an arc. Now join Q to O. So we clearly see this is going to be hypotenuse. And what is hypotenuse? Mathematically it is under root 5. So the length of OQ is going to be under root 5. Now the length OQ, take OL center with radius Q and draw an arc. Take OL center with radius OQ, draw an arc. It must be intersecting to this line at certain point in between 2 and 3. So this point, say this point is, you can say M. This point is M. So this M point gives the value of under root 5 on the number line. So this is geometrically representation of under root 5. So now your homework is to complete. Do these questions under root 2, under root 3, under root 7. This is your homework. Okay. Practice doing these square root values through geometrically. And hence the exercise 1.2 is over. So in the next lecture we will be discussing the next exercise. So if you have doubt, you can ask it. Thank you very much.